Alrighty, so today we're going to be reading DT graphs. When I say DT, I mean displacement time graphs. Sometimes they're called PT, P is in Peter, position time graphs, displacement time graphs, same thing. Okay, so you're going to be able to find displacement from a DT graph and find average velocity from a DT graph. For sure, I'm thinking you did the first one in grade 10, probably about half of you, depending on who you had and how far you got. I'm guessing the second bullet point here, finding average velocity, will likely be new to you. But good news is, it's easy. You already have the skills, you just don't know it. Okay, so you should have the handout with the train. Thanks, Andy. Let's begin. In order to illustrate the concepts of position displacement, we'll use the locomotive, a train moving back and forth in front of the station as it shunts rail cars, as it moves them back and forth, puts them into position. Remember, the track is straight. The train station is our reference point for analyzing the motion of the locomotive. We're going to call the train station position 0. It's our origin. It's our frame of reference. As we stand at the station, we notice that the locomotive is 30 meters to our left. Sometime later, it's right in front of us, and still later, it's 40 meters to our right, and later still, 10 meters to our left again. It's moving back and forth. We could draw a diagram to represent the various locations of the locomotive as they're measured from our reference point, the train station. Do you have the X1, X2 on yours? You do? Okay, good. So it starts 50 meters to our left, so X1. X just is referring to position here. Okay? Later it's right in front of us at 0, X2, X3 it's at plus 40, and then later on it's at minus 10, and so on. Okay? Remember that plus and minus stuff, right? To the right is positive, to the left is negative. All review, right? Good. If we were to analyze the motion of the locomotive, we would need to know its change in motion as it moves back and forth in front of the train station. Anytime there is a change in position of an object, we say that it has undergone displacement. In other words, displacement is a change in position. Displacement is a change in position. And displacement is actually, you might remember, a vector quantity. How come? Because it's got a side and it's got a direction. The direction might not be north or south, but it might just be positive or negative. That's also a way of describing direction. All good on that page? Okay, so displacement is a change in position. To determine any change in position, we would subtract where we started from where we ended up. Okay? Displacement is, or delta x, sometimes delta d, delta x and delta d are kind of interchangeable, is equal to xf minus xi. Have you got that there on your page? Good. That's sort of kind of a formula. It's so simple that we don't really use it, but it's kind of a formula. X stands for position. The symbol delta, the triangle thingy, so the Greek letter D, by the way, is a much used symbol in physics which indicates a change in something and always subtracts the initial reading from the final. So it's the final one first, final minus initial. Dan and I are playing 21 down at the gym. Dan has 18 points, and he started with 15. What was his change? How much did he just get? 3, right? Final minus initial. I've often wondered, this delta D, this Greek stuff, like, is there a class right now in Athens where the teacher's going delta for displacement? How do they deal with that? They speak Greek. It's Greece, man. It's Greece. It's still a language. There's modern Greek and there's ancient Greek, but it's still Greek. Yeah. I'd like to really know that. I was in Greece a few years back, and I really wanted to ask a bunch of people if my wife knows that because she thought it was weird. And I really would like to know what they teach in science class, what they use. Maybe they do this. Maybe they go D and then like that, right? It's the opposite. I don't know. We gotta find an exchange student from Greece so I can find it. Andy, you must know someone in Greece. No? I'm gonna put you in charge to find that out. Anyways, so the delta is change in something subtracts the initial from the final. The displacement of the locomotive for the first interval can now be calculated. Where did it end up? It went from minus 50 to 0. Now you might be saying, okay, Mr. Mann, you're making this way more complicated than it needs to be, and you're right. But the reason we're doing that is we're kind of building some foundation for future knowledge, right? We're starting at minus 50, we're at x1, and we're going to x2, position 2. Obviously, I went 1, 2, 3, 4, 5. I went plus 50, right? That's my displacement. Everyone can see that, right, Josh? Plus 50. Why am I making it so complicated? I'm going final minus initial. What's my final position? 0. What's my initial? Minus 50. So when I go final minus initial, 0 minus 50, and I picked this one for a reason, right? Because you have to be careful when you've got a negative here that you actually subtract it. Be careful. 0 minus 50 is a displacement of plus 50. The math works out, even though we can see it. I mean, you don't need to be a mathematical genius to go from minus 50 to 0 and realize that your displacement is plus 50, right? Everyone's good? Okay. This tells us the locomotive moved plus 50 meters in a positive direction, which is to the right. Here's what I want you to do now. Calculate the displacements for the other two time intervals. I've given you an example. Now you take that knowledge and you're going to apply it. So I'm going from x2 to x3, and then you're going to go from x3 to x4. Go ahead. First I have to start the question, which I will do right away. Okay. So you have to enter in on your clicker the number for the displacement from position 2 to position 3. I've shown you an example. I hope you were listening. Okay, so what you get here is that we're all going to get it right? Correct answer is minus 50. How come minus 50? It's going to be, right? It's going to be minus 10 subtract 40 minus 50. Displacements. Okay. So, do you guys have all these questions now? You should have them there, right? I think this is a multi-question little quiz here. So you got state the displacement for each of the following changes. There is 1, 2, 3, 4, 5, 6. Oh, and number 6 here, you have to match which ones are the same. I'll leave this up on the screen. You guys go ahead and do questions 1 to 6. Okay. Oh, I got to hit stop. I'm hoping, yay, everyone got 27? Pretty easy, right? From mine, 27, that's not right. Correct answer is 6. I'm looking at that number. Correct answer is 6. It's 7. Minus 10. Uh-oh. Uh-oh, what's going on there? Final minus initial. Minus 8 minus 2 is minus 10. 0 to 8. Oh, really? 8 minus 0, you guys. Final minus initial. Minus 8 to plus 20. Final minus initial. 20 minus 8. 28. Minus 8 plus 8 to minus 8. Oh, geez, you guys. Minus 16, right? Okay, which ones are all the same? It's answer B. It's A and C are all the same. Right? Come here, you. What are the displacements? That's going to be 3. This is going to be minus 9. That's going to be plus 3, minus 3, plus 2, minus 3, plus 5, right? Okay, so the two that are the same are right there. I'm thinking most people can do it now. Reese, put it away, man. The learning part. Mom can deal without you for half an hour. She'll be okay. You don't have to talk to Mom. Okay, now, that's the easy part. I hate to tell you this, that's the easy part. Okay? Displacement from a position time graph now. Okay, we're going to be reading it from a graph. Pay attention, here's the learning part. There's going to be a little quiz part later. Knowing the position of an object tells us something about the motion of that object, but it would be helpful to know the length of time it takes to undergo the displacement. Displacement and time can both be illustrated at the same time on a position time graph or displacement time graph. The position time graph is capable of providing us with information about displacement, average velocity, and instantaneous velocity. And we're going to be dealing with all of them. These three calculations will be performed using the sample position time graph shown below. You will notice here that all of the parts of the graph, the lines are straight for now. Displacement is determined on a position time graph using the standard formula. Displacement is delta x is equal to xf minus xi. Now, before we go any further, when I say the delta x, I don't mean the x coordinate of the graph. Okay? The x is position. So that is my air quotes x. X standing for position. Okay? This is my t, time. Okay? Not x and y kind of thing. The final and initial positions are located on the vertical axis. This one right here, vertical. And if you desire, a dotted line can be drawn from the graph to the position coordinate in order to easily identify the two positions. If you need to draw a little dotted line across, you go right ahead. Cross. In the example graph for time interval A, delta x, or xf is 6 and xi is 0. I'm going to do this example. I'm going to tell you what's on the next screen. What do you think it's going to be? You're going to do some. So listen up so that you don't have to try to figure it out on your own. I'm going to show you right now. We're going to find the displacement for interval A. See the intervals here? A, B, C, D, E, and F. They are the different, here's A, B, C, D, E, and F. The different parts. Okay? All right, so what is the displacement for A? What's the final position? 6. Am I looking at the time? No, I'm looking at the y, the position here, right? So it's plus 6. The final position is 6. What was the initial position? 0. 6 minus 0 is 6. I went to the right 6. Don't say you go up 6. Why is it going up? Well, that's because the time. What time is this point right here? That's 5, so this one here is 2. Okay, right? 1, 2, 3, 4, 5. But I'm dealing with the position. Position here is 6 minus 0. Okay, now you guys go ahead and do intervals B, C, D, E, and F. It's on the clicker. Go ahead and find the displacements for B, C, D, E, and F. You'll notice that there are, no, I was going to say, you might have six questions, I'm not sure. Everyone is done. Let's see how you did. Yay, everyone got it? Interval B is 0. How can you tell it's 0 without even doing the math? It's flat. It's flat. Number 2, I'm going from 6 all the way down to minus 10. That's the displacement of minus 16. Interval D, again, is flat. Who got that wrong? It's flat. It stays at minus 10. Interval 4, or E, it looks like it's going up 6 from minus 10 to minus 4. It's plus 6. And the last one, did I give you the answer? That is the last one, right? Oh no, this one here. Answer's 4, right? It goes from minus 4 to 0. Okay, not too bad. All right, next step, we're going to calculate the average velocity for each interval. How do we find average velocity? You know from grade 10, it's v bar is d over t. Where do we get the d, the displacement? From the graph. It's what you just did. What you just did. How do we get the time? Do the same thing, but for the time. So here's your example. You're going to have 5 to do right away. Right? So interval A, the displacement is from 0 up to 6. That's where the 6 comes from. Where does the time equal to 2 come from? Because it took 2 seconds. 2 minus 0. How much time is interval B? 6 minus 2 or 4. If you want to count, 1, 2, 3, 4. 6 minus 4. So the average velocity for interval A is the displacement, which is 6, up 6, over 2. Hey, that sounds an awful like I said, up 6 and over 2. That sounds a lot like slope. What are we finding? We are finding the slope. The average velocity is the slope. Did you know that from grade 10? Probably. The average velocity is the slope. Okay, so you need to find the average velocity for intervals B, C, D, E, and F. You've got the displacements already. Some of you got them wrong, so I hope you copied down the right answer. Please begin. One. It starts on B. Oh, it looks like these are individual questions, are they? Okay, it looks like I've done B first. Okay, let's do B first, and then I'll give you the answer, and then we'll move on. So it's displacement divided by time. Look at the displacement that you got for interval B, and you divide by the time. Yeah, there's only one question. It looks like I said, let's do this first one, get an answer, and then move on. Thank you. Just one question. You can? No, it doesn't make you wrong if you don't have a fraction. Don't quote me on that, guys. You're just doing B, right? You're just doing B for now. There's only one question. And it really shouldn't take this long, you guys. Like, I hate to tell you this, but this is about a 3-second job, and 2.5 of that seconds is picking up the device, putting in the number, and pressing enter. You won't even need a calculator for this one. I'm giving you 3 more seconds. Did you press enter, Megan? What's the answer, Alex? 0! What does the flat line mean? We did it yesterday. What does a flat line mean for velocity? It means it stopped. It stopped. Do you need a calculator to tell me what the slope of a flat line is? I don't think so. The slope is 0. It is stopped. Way to go, Alex. Give yourself a high five. I had 0 and they said it was a high five. Don't listen to them. Guys, start listening to him. I got it right. Okay, go ahead and do C. Go ahead and do C and D and E and F. Oh, and there's one more after that. It's still one question? Oh. Okay, we gotta do them one at a time. Fair enough. Okay. You see. Correct answer? -4. That's how long it should take it.
Yes.
-4. How come? What's the displacement? It ends up at -10. It started at 6. -10 subtract 6. The d is the displacement. It's the one thing part we did before. We started at 6. We go down to -10. That's a displacement of -16. The time is only 4 seconds. 10 minus 6 is 4. 16 over 4 minus 4. Go. Literally 3 seconds, you guys. This had better be all right, or I might throw a tantrum here. Yay, 0. How come? It's flat. E, interval E. Displacement divided by time. Will, are you going to press enter? Correct answer is 6. There's the work on the screen. I go from, it's final minus initial, right? So here my position is -4, subtract -10. -4 subtract -10 is +6. My time is, this is 12, this is 13, so my time is 1. 6 over 1 is 6. 6 what, by the way? Meters per second. How do I know it's meters per second? Meters per second. Once again, just like in Unit 1, the slope means something here. The slope means the velocity. Okay, last one. Come on, let's aim for 100% here. You're finding the slope. $100%? Me. You're ruining my day. What is the slope? D over T. We're almost done, you guys. The final position is position 0. So it's 0 minus -4. All over my time, which is 10, 11, 12, 13 to 17. 17 minus 13, which is going to be 4 over 4, which is 1. 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 4 over 4, whi 1 meter per second. 1. Okay, last one. This is a yes, no. Do I have to start it? Yes, I do. Given this position time graph, determine if this represents a real life situation. It's Y or N. Yay! How come?
Can't go backwards in time.
Can't go backwards in time. And he pointed out we do have daylight savings where there's a. Not only can you not go back in time, but I prefer to look at it this way. Can you be at 2 hours? Can you be in 2 different positions? Because that's really what it's showing. Okay, one more thing before you go. Hang on. I know you've taken in math class, many of you, the vertical line test, right? Remember the vertical line test? What does the vertical line test say? Not a function. Is this a function? No. In fact, almost always textbooks talk about position being a. Don't back up. Position being a function of time, because you can't be in 2 positions at the same time. Okay. What I'd like you to do for a little bit of practice, you've got 2 sheets in the back there. Okay? I would like you for tomorrow to have the first one done. We've got a little bit of time right now. I only want the first one done. So that's question A to J. I've given you answers. It's about a 10-minute little job, if that. If you get started. If you do it right now, you'll get it done in time. Okay? Go.